Hey everyone, welcome back to DIY Biotech. Today we're doing another video in the series, A Bioengineer Makes Kombucha. So we have our petri dishes made and we have some fermented beverages and products that we want to test. Today I'm testing two different kinds of kombucha, a kind of yogurt, some almond yogurt that I think might be interesting, as well as a homebrewed kefir. In addition to, of course, plating these microorganisms, I also want to sort of pull out all of the testing that I can do on these beverages just to maybe get a little bit more information. So I'm going to be testing their glucose content, their pH, as well as their alcohol content, just sort of out of curiosity. So hopefully everybody at home has their petri dishes made and we are ready to start plating some things. Today we're going to actually isolate some bacteria and some yeast. Maybe in future episodes we'll do further identification of the organisms, and next episode I'm really excited to try out using these microorganisms from the petri dish to make some sort of crazy witch's brew beverage. Okay, so here's everything we need to get started plating. So we have our petri dishes, we have one of each plate, we have PDA with ampicillin, LB with ampicillin, and just regular PDA. We also have our alcohol lamp from the last episode. And in addition, we have this inoculation loop. I just got this from Jeff Bezos on Amazon, so it wasn't too expensive. But it's a nice little tool to have. You can really use anything that can spread something sterilely onto the petri dishes. So again, here's our first kombucha. Here's our second kombucha. These are both popular store-bought brands. We have our oat yogurt, which I added a little bit of water to, as well as our regular yogurt, both of which advertise that they have live bacteria in them. And then finally, the homemade kefir, and this is what I'm most hopeful for. I have a feeling homebrewed products are going to have more microorganisms. And again, we have our trusty spray bottle for sterilizing our surfaces and our hands. So as I mentioned, we're going to try to test everything we can. So here's the little alcohol tester, Rare Combinations alcohol tester. We have some glucose test strips. I had these from another experiment that I did, and then some pH indicator paper. This isn't exact, but it will at least give us some information. Okay, as always, we're going to spray down our surface whenever we're going to work with sterile cultures, and of course have our alcohol lamp or candle or whatever you have on hand to have some sort of updraft and prevent contamination from falling onto your plates. Okay, so first we're going to start with these LB plates. With an inoculation loop, it's very important to sterilize it in the flame. So we're going to wait until the loop gets red hot in that flame, and we're sort of pointing it downwards so that the length of the loop is sterilized. And since we're pulling straight from a liquid culture, cooling the tip down in the liquid isn't going to hurt any of the microbes. So we're just going to swish it around in there. Open our plate as close to the flame as possible and just do a little bit of a zigzag in the wedge that we've separated for this sample. Okay, so that was the first one, and we're just going to repeat this procedure for the rest of the sections of the rest of the plates, one at a time, again sterilizing the loop. Red hot right there. Going into the sample, swishing it around a bit to get some organisms onto the inoculation loop. Again, we open the plate as close to the flame as possible for as brief an amount of time as possible to prevent contamination. Quickly do our little zigzag and put it back on its lid. Okay, again, we have our test strips, pH and glucose. These glucose strips are pretty easy to use. It's just colorimetric test strips. You just swish it around for a few seconds, and it actually takes a few seconds for the color to change, so you have to leave it out for a second. And then you can just compare the color to the key on the bag, and it tells you a rough approximation of the glucose content. So the glucose can potentially tell us a little bit about how much sugar is still left in the solution. Again, this is just a test for glucose. Glucose is not all sugars. There's sucrose, there's galactose, there's lactose, there's a million different kinds of sugars, but at least we'll have some idea of the sugar content potentially. Okay, so now we have our pH paper. This is even easier to use. You just dip it in, you don't even have to swish it around. and then we'll compare it to the key again on the little cardboard container that these come in. Here are all of the results. You can see all of our solutions are acidic in some way, and a couple of our solutions still have some glucose hanging around. Just sort of interesting. Maybe this will give us some information later once we isolate our yeast. Okay, here's our alcohol tester. First, I'm screwing in our 0.5% sample. This just gives us sort of a baseline. There's more accurate ways to use this device, but I just want sort of a rough estimate to know whether or not these samples are above or below 0.5%, just out of curiosity. So this 0.5% sample is a little cold because it's reading 0.42-ish. So I'm gonna warm it up. A warmer sample temperature gives us a higher alcohol percentage. So once we reach a temperature that reads 0.5% on the detector, we know that's about the calibration temperature. So it looks like about 20.3 or 20.5 degrees Celsius is the correct calibration temperature. So that means if all of our samples are 20.5 degrees Celsius, then we're probably getting an accurate reading. All right, so we're gonna test our first kombucha. Again, this is a pretty popular store-bought brand. I don't wanna expose these guys for their alcohol content, but I can tell you it's almost certainly higher than 0.5%. Again, I'm not gonna say whose kombucha this is, because potentially I could have some measurement error here, but you can see it's reading 1.3%. The calibration temperature is a lot higher than it should be, so it is reading higher than it should, but based on using this device a lot, this is probably around 0.75 or something along those lines, but certainly over 0.5%. So now I'm going to read the second kombucha sample as well as the kefir sample. All right, so here are the results from all of the tests. We have rows for our kombucha samples, our oat yogurt, our regular yogurt, and on the bottom we have our homemade kefir. So you can see the pH, the glucose, and alcohol content. Again, that first kombucha was about 1%, the second one was about 0.15, and our kefir was about 0.5%. All right, so it is a couple days later. These have been in a 30 degrees Celsius incubator. You can watch my video on the fridge incubator if you would like to see how I made that. The PDA plates were not very good. I would not recommend making these. I said this in the plate making video that this PDA is just something's not right with it. It needs something added to it. So, maybe it's good, but maybe something needs to be added. Potato dextrose agar is also a less viscous agar, so it needs to be cooled down more. It just has different properties from the regular LB agar that we're used to. There are some colonies on it though. We do see some colonies. Of course, there's a lot more growth on the PDA plate without antibiotics. Okay, let's look at these LB plates. I think they show a better idea of these organisms. So this is the LB with the ampicillin, and you can see that this first store-bought kombucha has some really cool looking colonies. The kefir has these really tiny white colonies. I think they're pretty cool looking too. The rest of the growth is sort of pretty hard to see. There's a tiny bit on the yogurt ones, but it's hard to tell if I just put a thick layer of yogurt on and there's still yogurt on the plate. But the store-bought kombucha as well as the homemade kefir grew really well on these LB with ampicillin plates, suggesting that these colonies are yeast. The LB without ampicillin is a bit of a mess. There's colonies everywhere. There's large colonies and small colonies and lawns, which is basically just a sheet of organisms. But you can see there's colonies from the first kombucha and from the second kombucha. From the first kombucha, there's this one large colony. It could certainly be contamination, or it could just be some organism that grows very quickly. The homemade kefir is also interesting on this plate. We have sort of a lawn looking thing, and then we also have these individual colonies. And these actually look very different from the LB with ampicillin colonies. So maybe these are potentially two different kinds of bacteria. And then on the LB with ampicillin, we have isolated a strain of yeast. Okay, so now I'm going to show a technique called patch plating. So here we're going to divide up our plate into 8 sections. Of course, you can divide your plate up into much more. Oftentimes, patch plates are done with 100 individual squares, which is a pain to do. But the idea of this is to screen different colonies of organisms for growth on different substrates. So here what I want to do is compare the growth of these organisms on LB plates with no antibiotic and LB plates with ampicillin. So now we're going to identify the different organisms that we want to patch plate on our plates. The oat yogurt doesn't really have much of interest to me, but all of the other segments of our plate have 2 colonies of interest each, and so we're going to do 2 patches of each of the numbers. So I'm just doing A and B of each number. All right, so we have our sterilized work surface. We are heating up our inoculation loop. Once our loop is red hot, we're going to take it out of the flame. Again, holding the plate as close to the flame as possible. We're going to cool it down in an empty section of agar. And then we're going to scrape up a little bit of our colony. You don't need a huge chunk on the loop. Again, microorganisms are very small, so you don't even have to see it on the loop. You just have to touch it to the colony. And then we're going to do 3 streaks on the patch plate. You can do zigzags if you want. You can do 4 streaks if you want. But here, I'm just doing 3 streaks. That's just how I was taught. So that's what we're doing here. All right, again, we're going to touch our hot inoculation loop to an empty section of agar. We're going to touch our colony. Looking back at the footage, I realized I didn't actually grab this colony at all. So we're not going to get any growth on this square. But again, we're going to do those 3 streaks and repeat for all of the other colonies. So the purpose of this patch plate here is to simply transfer these organisms to a new LB plate in order to isolate them a little bit better. You could go directly from the LB plate to an LB plus ampicillin plate if you wanted. That's probably more efficient, but I just wanted to see them grow on LB for sure again and make sure I have sort of unique colonies and I'm not accidentally picking up a few colonies when I'm pulling from the original streak plate. Okay, you can see I messed up some things here. I ended up going back and looking at the footage and figuring things out, so it's fixed on the next plate. All right, so here is our finished patch plate. You can see everything grew except the 1B up in the top right, because again, I missed that colony. And you can see I also ended up looking back at the footage and correcting the patches that I put in the wrong spot. So this patch plate was grown again at 30 degrees Celsius in my little refrigerator incubator, and it took about 2 or 3 days to grow to this density. Okay, so I'm really interested in this kefir yeast with these really tiny colonies. I think these are really cool looking, and I want to isolate them and actually see if it's yeast or not. I'm also interested in this 1B because for whatever reason I think this is a yeast. Again, this is a colony from the popular store-bought kombucha with higher than should be alcohol content. So here are some plates that I've set up for our streak plating. So this is a different kind of streak plating for isolation. And we're actually doing these on LB with antibiotic plates. And so the method for streak plating for isolation is to do a little zigzag like this, turn the plate, do another little zigzag, turn the plate, do another little zigzag. And at the beginning of each zig, you're going to pull some from your previous zag. And you'll see what this looks like in a second. Between your sets of zigs and zags, you can actually sterilize your inoculation loop if you want, in order to potentially more precisely isolate colonies. Or if you think you don't have very many organisms on the loop, you can just not sterilize the loop in between each zigzag. I'm also going to be doing another patch plating onto an LB with antibiotic plate just to see what grows on that. Okay, so we have our sterilized work surface, our flame heated loop. We're going to cool it down in the agar. We're actually going to pull the 1B colony this time. Really made sure of that this time. And so again, we're going to do our zigzag, rotate, zigzag, rotate, zigzag, and that first pull we're pulling from our previous zigzag, rotate, zigzag. So that should in a way sort of dilute our organisms. This is a very commonly used technique in labs, so I'm going to show it again, this time in slow motion. Just kidding, not in slow motion. I think I go slow enough here. So again, cooling our loop in the agar, pulling some colonies from our patch, little zigzag there, pull from our previous zigzag, pull from our previous zigzag, and this isolates our colonies. So again, between those zigzags, you could heat the loop and then pull from the previous zigzag. That's probably a better way to isolate colonies, but this ended up working as well. All right, now we're gonna do our patch plate from our regular LB plate to our LB with ampicillin, cooling down our loop in the agar, pulling a streak from the patch, putting it in the new patch with 3 streaks, and then I just repeat this procedure for the rest of the colonies. All right, so now we have our little deck of petri dishes. Let's take a look. So this is the regular LB plate. This has been stored in the fridge. What I do to store them is I actually tape some electrical tape around the plate to prevent evaporation. Here's our LB with antibiotic plate, and you can see only 3 colonies grew. The 2 from the water kefir, and then 1 from the kombucha. So potentially these are yeast. However, I'm doubtful of the 1A sample because this was the colony that was very large, and you can see in the LB plate it grew very quickly. So potentially this is just a very robust bacteria or something along those lines, and it could have somehow broken down the antibiotic to live just a little bit. So I'm really confident that I isolated some kefir yeast here. These could be 2 different strains, or I could have just pulled from the same strain. You can see our water kefir yeast grew really well, but our 1B kombucha sample did not grow well. I thought this was a yeast. I don't think that's true anymore because it did not grow on the antibiotic plate. So the only yeast that we isolated is this water kefir yeast. You can see the patch plate worked really well. We have on our first zigzags some pretty dense colonies, and then on our last zigzags we have mostly isolated colonies. Again, heating up the loop between the zigzag is a good idea. And you can see when I pulled from the previous zigzag, sometimes I double dipped there. Really pretty tiny white colonies. And I actually ended up taking a picture of these under the microscope. You can't see much in the picture, but maybe I'll get better at my microscopy skills at some point. So this is sort of my prized possession now, and I want to use it in the next video to make some sort of beverage with it. So I'm going to use the same media that water kefir normally uses and grow just the yeast. So potentially more alcohol could be produced in this kefir than regular kefir because there's no bacteria to break down that ethanol. Potentially. I don't really know what I'm doing. All right, I hope you enjoyed looking at my petri dishes, and I hope this video has been helpful to get everybody started on growing microorganisms on petri dishes in a way that helps you study them and use them for new applications. In the next video, I'm really excited to try out using some of these microorganisms. I'm going to try using the water kefir yeast, and I guess what you would call a single organism beverage rather than a consortium of organisms, and just see what happens. I think it'll be interesting. Maybe the pH won't drop since it doesn't have acid producing bacteria. You know, maybe it'll be higher alcohol content since it doesn't have those bacteria. Maybe it won't ferment at all. I really don't know what will happen, but I think it will be interesting. I've also considered making some sort of bread with the yeast that I've isolated. So using water kefir yeast to make bread. I think that would be sort of interesting to see what happens. I think the Thought Emporium sort of had a similar idea, but I think most of his yeast were isolated from natural sources. If you have suggestions for strange fermentations that I should try out, please leave them in the comments below. And I hope to extend this series with just a bunch of different individual videos of using different organisms for strange fermentations. So again, if you have suggestions, leave them in the comments below. Thank you so much for watching, and if you enjoyed the video, please like and subscribe. I'll see you in the next one. Bye.